Today we are going to show you the application of this fuel consumption meter AVL PLUtron CLASSIC to this GDI vehicle for in-vehicle fuel consumption measurement. But first, let's take a look at a schematic of this setup for a moment. In this schematic, you can see a typical fuel supply system of a gasoline vehicle without return line to the tank. A tank pump module including pressure regulation and filter supplies fuel into a chassis-mounted fuel line. This line leads to the engine compartment and supplies fuel at usually 4 to 8 bar pressure to the engine. When a flow meter is supposed to be mounted for chassis dyno or road testing, we need to find a non-destructive way to access this line. Usually there are quick connectors found at the tank pump module and in the engine compartment close to the engine. Flow meter position should be chosen as close to the engine as possible to minimize environmental influence. So the best position is inside the engine compartment. In case there is not enough room to fit in the meter, the second best position is just above the tank module. We will see later how to access those connectors. For mounting the flow meter mechanically to the chassis, a suitable fixture or bracket usually has to be fitted to the individual mounting situation. The flow meter also has to be connected to a power supply. Usually the vehicle battery is used. CAN data loggers are typically used for data acquisition and vehicle testing. AVL PLUtron directly connects to the CAN bus interface of all standard data logger devices. Additional vehicle parameters like vehicle speed, engine speed or load are recorded via OBD from the engine electronics. An optional mobile display can be used during setup and later inside the car during test drives for online monitoring of the fuel flow rate, density, pressure and temperature. For vehicles with direct fuel injection, the flow meter setup is identical. And AVL PLUtron is the only flow meter which can deal with the pressure pulsations from modern GDI high pressure pumps and which can be mounted close to the engine. First of all, we are going to look for a good spot where to mount the AVL PLUtron flow meter into the engine compartment. It looks like there's some nice spot around here where we could fit in the flow meter. There's a space, maybe we could mount it like this or the other way around like that. This should be a very nice positioning. Of course, we need to find some fixture for it. The AVL flow meter has two 8mm metric mounting threads on each side and on the bottom where a fixture can be mounted. An appropriate counterpart for mounting the fixture to the chassis has to be identified preferably close to the flow meter position. The fixture itself can be made from 3 or 4mm sheet metal strips which have to be bent and may be welded to fit in the flow meter in the intended position. Make sure to leave some extra room for cables and hoses on the sides and in forward direction. Next, we will look for the hydraulic connection where we connect into the supply line. So I remove this cover to better see what we are looking at. We can see the high pressure pump over here. It's a GDI piston pump, mechanically driven. And it has back here the high pressure metal line that goes out here, over here. Then it has the supply line coming from top, connecting over here. This is important for applying a flow meter. You have to connect into the supply line that comes from the tank to the engine. And you have to check there's no return flow to the tank. The second line that you can see here is not a return flow to the tank, it's just a regeneration line for the canister that collects the evaporations from the tank. So this is the line we want to connect to, and this connector we're going to use later on for connecting the flow meter and taking lines over here where we then connect to the PLUtron. The other possibility to connect to the supply line is to access the tank module. Usually there is an access under the back seat of the vehicle. So for now we are going to check and remove the back seat of the vehicle. And here we see the access lid to the tank. Okay, now we're going to remove this lid, and underneath we should expect to find the tank pump module. Here we go. So this would be the alternative connector to the supply line. That's where it starts and comes from the tank. This is a tank pump and filter, pressure regulation, everything. Such hose connectors to the standard quick couplers are available in different sizes. Most common in passenger car is the size 5/16 inch, which stands for the outside diameter of the male connector. The PLUtron sensor later on can be mounted on ISOFIX fixtures right above. Primarily the point is to install as short lines as possible. An alternative position for the flow meter is in the trunk, for instance in case fuel lines inside the passenger compartment are not permitted. And in case there is no tank access from under the back seat, then the vehicle has to be inspected from underneath to find the quick connectors close to the tank module. The extra fuel lines to connect the flow meter will be somewhat longer, of course. This will increase the environmental influence and reduce flow rate signal dynamics a little, but average consumption measurement will still be accurate. Mounting the flow meter in a drip pan is always a good idea when quick connectors are also used on the PLUtron flow meter fittings. Our optional self-closing quick connectors are somewhat more cost intensive, but a perfect way to avoid fuel spill when disconnecting the meter. For electrical connection we need to connect to the mass or minus pole, of course, and to the plus supply of the vehicle, which connects to the battery in the trunk. So supply connection for the PLUtron flow meter we will connect here and here. So after having gone through the needed preparation, we are going to show you next the complete installation procedure. As a first step you will see the mechanical installation of the PLUtron flow meter. Then we will connect and purge the fuel lines, and as a third step we will show you the electrical connection. After everything is ready we will power up the sensor, check its function, then record some data on the road and finally take a look at them on the computer. So let's start with mounting the PLUtron flow meter. Okay, first of all we need to mount the fixture. We have prepared before down here the threads that have been introduced to the chassis, and the fixture of course has been prepared by welding some steel material. After fixing the screw connections to the chassis, we can now mount the PLUtron flow meter to the fixture. But before continuing with mounting the fuel lines, we are going to disconnect the vehicle battery. For safety reasons we are going to disconnect the battery, as the fuel supply pump may start to pump as soon as we open the line and pressure goes down. So we disconnect the plus pole of the battery. For safety. So now we are ready to connect the fuel lines. We will start with opening the quick connector of the supply line between the tank and the engine, or in this case between the tank and the high pressure pump. Be careful, this line could be under pressure, so a small amount of fuel could spill out as you open the connector. In this particular installation we remove this vehicle fuel line segment between the quick connector and the high pressure pump. And we are replacing it by two fuel lines, one going from the quick connector to the AVL PLUtron inlet, and the second one going from the flow meter outlet to the high pressure pump. Before we connect this second hose to the pump inlet, however, we should flush some fuel through the hoses and the meter. Make sure the hose end leads into a bucket or other container to collect flush fuel before you reconnect the battery, as the fuel pump may start pumping as soon as you close the battery contact. Ignition, or even operate the electric starter of the vehicle in order to flush roughly half a liter of fuel through the lines into the bucket. Then power off the fuel supply again. Now connect the end of the second hose to the high pressure pump inlet connector. Now we are certain the right fuel is inside the flow meter, and in the same time we have purged the air from the hoses. As a last step, the fuel lines need to be fixed for safety. We are using zip ties to secure the fuel lines inside the engine compartment. Particularly the hose between flow meter and engine should be protected against vibration in order to avoid resulting oscillations on the fuel flow signal. Of course, this whole procedure differs a little from vehicle to vehicle. For instance, in case of a port fuel injection engine, the hose going from the PLUtron flow meter must be connected to the fuel rail instead of the high pressure pump, as in our example. Now we are ready for the last step, the installation of the electrical connections. First we need to remove the top cover to access the battery terminal connector box in the engine compartment for the power connection. Now we are putting the main connection cable in place, and then the CAN connection cable. For easier access we connect the CAN cable first to PLUtron. But before, a short instruction for connector handling. The connector locking ring mark needs to be aligned with a black bar on the connector. Then place it on the corresponding PLUtron connector in a 30-degree upward angle and push it on the connector. Then lock it by turning the ring until it blocks. Same procedure for the main connector. Now the cables can be placed into safe positions and fixed with zip ties. Check which terminals are permanently powered and which are switched on by vehicle ignition before connecting the main cable to the power terminal. Then connect the red wire to a plus 12 volt terminal. The blue cable must be attached to a ground terminal of the vehicle. Then we complete fixing the cables with zip ties. Finally, look for an electrical earth terminal to connect the braided metal band attached to the PLUtron connection box. Connection to the chassis or engine serves as a functional earth connector. Cable installation in the engine compartment is completed now, and we are almost ready to go. In order to connect a data acquisition device like a data logger or a notebook, we need to feed the CAN cable into the passenger compartment. When finished with fixing the cables, replace covers in order to minimize influence on the normal vehicle performance. We can use a notebook for a quick check of proper function of the flow meter setup. We connect the notebook with the AVL PLUtron device user interface software on it via Ethernet to the AVL PLUtron flow meter. The PLUtron Ethernet cable can be connected to the RJ45 socket of the notebook directly. However, it is more convenient to use an Ethernet USB adapter where we can permanently set up the IP address within the proper range to connect to AVL devices. For a quick function check, we can set up the notebook right next to the PLUtron in the engine compartment. We connect the Ethernet cable to the notebook on one end and to the PLUtron Ethernet connector on the other end. Remember, the connector locking ring mark needs to be aligned with the bar marking on the connector. Then plug it on the PLUtron connector marked with ETH and lock it by turning the ring until it blocks. The user software will connect to the device after a few seconds when it's powered on. When the engine is started, the numerical display on the left side will show instantaneous fuel flow and the online values of the temperature, density and pressure. It's an efficient quick check of device operation and plausibility of parameter readings. The optional mobile display is an even simpler way to quick check device operation. For a quick function check, we also set it up in the engine compartment. We just need to connect one cable to the PLUtron CAN2 output for powering the display and streaming measurement data. When the PLUtron flow meter is powered on, the display boots and switches into online mode, showing the volume flow. The mobile display serves conveniently to monitoring measurement values throughout vehicle testing. It can easily be mounted to the front screen with its suction cup mount. The connection cable needs to be fed through to the engine compartment where the PLUtron flow meter is mounted. Remember, the connector locking ring mark needs to be aligned with the bar marking on the connector. Then we plug it to the PLUtron connector marked with CAN2 and lock it by turning the ring until it blocks. We complete the installation by fixing the cables with zip ties. When the PLUtron flow meter is powered with engine start, the display boots and switches into online mode, showing the volume flow. Connecting the onboard diagnostic interface of a passenger car with a CAN data logger is the easiest way to access vehicle operation data to combine with the fuel consumption measurement. The standardized OBD connector, pin layout and output parameters are universal for all car makers. However, message protocols are individual. Here we are using a CSM CAN data logger to connect PLUtron and the OBD interface for collecting all parameters in one database. Power supply for the data logger is provided from the OBD connector. A split adapter is used on the data logger for connecting multiple CAN devices. The OBD cable is connected to one of the CAN inputs via a 120 ohm terminal resistor adapter. The second CAN input on the split adapter is used to connect the PLUtron CAN cable. Here we are using another 120 ohm terminal resistor adapter. Now we are almost ready to start our test drive, where we will record measurement data with the CAN logger from AVL PLUtron flow meter and from OBD in parallel. Of course we would like to monitor measurement data during the test drive, but we have no display for the data logger. So the co-driver will use the notebook and AVL PLUtron device user interface software to monitor our test drive. The connection cable needs to be fed through to the engine compartment where the PLUtron flow meter is mounted. The connector is plugged to the socket marked ETH for Ethernet. Remember, the connector locking ring mark needs to be aligned with the bar marking on the connector. Then it can be easily plugged and locked even in poorly accessible positions. We complete the installation by fixing the cables with zip ties. The user software will connect to the device within a few seconds after it is connected to a powered PLUtron. The numerical display on the left side will show instantaneous fuel flow and online values for temperature, density and pressure. So finally we have completed the installation of the PLUtron flow meter. We have done the mechanical fixture, we've done the electrical connections, and we have done the hydraulic lines, and everything is nicely fixed into the vehicle and prepared for measurement. So we are ready to go for the road. The co-driver is monitoring data collection with a notebook. The AVL PLUtron device user interface software is running on the notebook for monitoring our test drive. The numerical display on the left side shows instantaneous fuel flow as well as temperature, density and pressure. The graphical display allows to follow dynamic fuel consumption traces during transient driving situations. For this measurement we are using a PLUtron CLASSIC 100 flow meter with a measurement range from -10 liter per hour to 100 liter per hour fuel consumption. It also has the optional density meter integrated, so we are also measuring density and fuel mass flow in kilograms per hour. For recording the PLUtron measurement data with 10 Hz data rate, we are using a CAN data logger. For simultaneous recording of vehicle operation data, the CAN data logger is also connected to the onboard diagnostic interface of the car. This setup combines recording a large number of parameters with high data rate. And most important, it is simple and fast in setup. For measurement data analysis, we have loaded the data record file of the CAN data logger into AVL Concerto, which is a powerful tool for measurement data analysis. On the right-hand side, you can see the complete channel list of all recorded channels from OBD and AVL PLUtron. The bold data records have been included into the graph via drag and drop from this channel list. In the graph you can see from bottom to top fuel mass flow, engine load, fuel supply pressure, and engine speed. The top graph are two records of vehicle speed, one from the ECU and the other from GPS. The x-axis shows time in seconds, so the total record time was roughly 30 minutes. From engine speed in red you can see the engine was stopped and started in the beginning, then idling for about 5 minutes, and then a city cycle follows in two sections with several start and stop events and a few minutes idling in the middle. By activating the red cursor line, we get a numerical display on the top of the graph, which shows each parameter value at the intersection with the red cursor line. If we want to look at the data in higher time resolution, we can easily zoom in by marking a section of the x-axis. Comparing the signal resolution, you can see OBD data are only updated once a second, whereas data from PLUtron are available with 10 Hz data rate.
So with this video we hope to have provided you with helpful information of applying the PLUtron CLASSIC flow meter to a fuel consumption measurement application in a vehicle. One last thing, if you do the same job, take some video. We have this very nice teamware here, and to everybody who provides us with a video of his application in a vehicle, we will send him this nice t-shirt here, polo shirt, and remember, Plutronize beyond limits. And thank you very much for your attention. Please look out for more videos on applications of our products.